Close your eyes if you like, or keep them open. It doesn't matter. You don't need to do anything at all right now except rest. Whatever position you're in is fine. Whatever thoughts are floating through your mind can stay there. They'll quiet down on their own. Tonight, we're going to spend some time thinking about something that seems so ordinary, so familiar, that you've probably never questioned it. And yet, when you really look at it, when you really think about what's happening, it turns out to be one of the strangest and most beautiful things in the entire universe. I'm talking about gravity. Right now, as you lie there, you can feel something pressing you into your bed. Your mattress is pushing up against your back, your shoulders, your legs. You've felt this your whole life. Every single moment of every single day, this invisible presence has been with you. We call it gravity. And here's what's strange. Here's what most people don't know. Here's the quiet secret that one man discovered over 100 years ago, sitting alone in a patent office, staring at the ceiling and daydreaming. Gravity is not what you think it is. It's not a force. It's not pulling you down. Something else entirely is happening. Something so unexpected, so different from what we learned in school, that when you finally understand it, you might never think about the universe the same way again. But don't worry, we're not in a hurry. There's no test at the end of this. If you fall asleep before we're done, that's perfectly fine. In fact, that's the whole point. The ideas will still be here, the universe will still be here, and you'll be resting, which is exactly what you should be doing. So let's begin, slowly, gently, one thought at a time. Think back to when you were young. Maybe you remember learning about Isaac Newton and the apple. The story goes that Newton was sitting under a tree when an apple fell and bonked him on the head. And in that moment, he had a brilliant idea. He realized that the same force that pulled the apple down was the same force that kept the moon circling the Earth, the same force that kept the Earth circling the sun. Gravity. Newton figured out that every object in the universe pulls on every other object. The Earth pulls on you, you pull on the Earth. The sun pulls on the planets pull on each other. Everything is pulling on everything else, all the time, across the empty blackness of space. And for over 200 years, this idea worked beautifully. It explained so much. It predicted the tides. It guided ships across the ocean. It helped scientists discover new planets. Neptune, the 8th planet from the Sun, was actually found because Newton's math predicted it had to be there. Scientists looked where the equations said to look, and there it was. Newton's gravity was one of the greatest achievements of the human mind. But there was always something a little strange about it, something that bothered Newton himself, and it bothered him until the day he died. Here's the problem. How does the Earth pull on the moon? The moon is almost 240,000 miles away. It's floating in the empty vacuum of space. There's nothing between the Earth and the moon except emptiness. So how does the Earth's gravity reach across all that nothing and grab onto the moon? Newton didn't know. He called it action at a distance, and he admitted that he had no idea how it worked. He said that the idea of one object affecting another without touching it, without any medium in between, was so strange that it seemed impossible. And yet his equations worked. The math was perfect. The predictions came true. So people just accepted it. They used Newton's equations for centuries. They built bridges and calculated rocket trajectories and landed spacecraft on other worlds. And they didn't think too hard about that uncomfortable question hiding underneath all of it. How does gravity actually work? How does one object reach across empty space and pull on another? Take a breath, let that question settle. You don't need to answer it, just let it sit there like a stone dropped into still water. Now let's move forward in time, to the year 1907, to a young man named Albert Einstein. Einstein was 28 years old. He worked in a patent office in Bern, Switzerland. His job was to examine applications for new inventions, deciding whether they were original enough to deserve a patent. It wasn't a glamorous job. He sat at a desk all day, shuffling through paperwork. But Einstein had a habit that would change everything. He liked to daydream. He would sit there at his desk, staring off into space, and imagine things. Strange things, impossible things, things that no one else was thinking about. One day, Einstein was sitting in his chair, probably bored, probably tired, and a thought floated into his mind. A simple thought, a thought that he would later call the happiest thought of my life. He imagined a man falling off a roof. That's it, just a man falling through the air, plummeting toward the ground. And Einstein realized something. While that man is falling, before he hits the ground, he doesn't feel anything. He doesn't feel gravity. He doesn't feel his own weight. If he had objects in his pockets, coins or keys or a wallet, and they fell out while he was falling, they would float right beside him. They would all be falling together at the same rate, and from the man's point of view, everything would seem weightless. The man is falling toward the earth. Gravity is definitely there, and yet, from the inside, from his own experience, there is no gravity at all. Einstein sat with this thought. He turned it over in his mind like a puzzle. And then he asked himself a strange question. What if that man was in a sealed box? What if he couldn't see outside? What if he woke up in that box, falling through space, and he felt weightless and objects floated around him? Would he know he was falling? Or would he think he was just floating, far away from any planet, in the emptiness of deep space? The answer, Einstein realized, was no. He wouldn't know. There would be no way to tell the difference. No experiment he could do inside the box would reveal whether he was falling toward Earth or floating in the void. This is strange, really strange, because it means that gravity, in a sense, disappears when you fall freely. It's still there. The Earth is still pulling, but you can't feel it. You can't detect it. It's like it doesn't exist. Let that sink in for a moment. Take another slow breath. Feel the weight of your body pressing into the bed. That weight, that pressure, isn't gravity pulling you down. It's something else. Einstein kept thinking about his falling man. He imagined more scenarios, more thought experiments. He imagined a man in a sealed box, floating in deep space, far from any star or planet. No gravity at all. The man is weightless. Objects float beside him. Everything drifts. Now imagine someone attaches a rope to the top of the box and starts pulling it upward, pulling faster and faster, accelerating the box through space. What happens inside? The man feels himself pressed against the floor. If he lets go of an object, it falls to the floor. Everything behaves exactly as if he was standing on Earth, feeling the pull of gravity. But there is no gravity. He's in deep space. It's just the floor accelerating up to meet him. Einstein realized something profound. Being accelerated upward feels exactly the same as being pulled down by gravity. There is no difference. No experiment inside the box could tell you which one is happening. This idea is called the equivalence principle, and it was the key that unlocked everything. Because if acceleration and gravity are indistinguishable, if they feel exactly the same, then maybe they are the same thing. Maybe gravity isn't a mysterious force pulling you down. Maybe it's something else entirely. Maybe what we call gravity is really just motion, just geometry, just the shape of reality itself. Now we're getting to the heart of it, the quiet secret that changes everything. But first, let's pause. Let's rest with what we have so far. You're lying there, feeling the bed beneath you. You've felt this your whole life. You've always called it gravity. You've always thought of it as a force pulling you toward the center of the Earth. But Einstein's thought experiments suggest something different. When you're falling freely, gravity disappears. You feel nothing. And when you're accelerated through empty space, with no gravity anywhere nearby, you feel exactly like you're in a gravitational field. So what is gravity, really? Einstein spent the next 8 years figuring that out. 8 years of the hardest work of his life. 8 years of struggling with mathematics, so difficult that he had to learn entirely new kinds of math just to write down his ideas. And in 1915, he finally got it. He published his general theory of relativity, and in it, he revealed the true nature of gravity. Gravity is not a force. Gravity is the shape of space and time. Let that settle. Don't worry if it doesn't make sense yet. We're going to take it slowly. First, we need to talk about something called spacetime. You already know about space. It's the three-dimensional emptiness all around you. Length, width, height, up, down, left, right, forward, backward, three directions you can move. And you know about time. It's the thing that keeps ticking forward, second after second, minute after minute. It's what lets you have a before and an after. It's what separates yesterday from today from tomorrow. Here's what Einstein discovered. Space and time aren't separate things. They're woven together into a single fabric called spacetime. Imagine a kind of four-dimensional fabric stretching out in all directions and through all moments. Everything that exists somewhere in this fabric. Every event, every moment has a location in spacetime, where it happened and when it happened, 4 coordinates, 3 for space, 1 for time. Now here's the key idea. This fabric isn't rigid, it's not fixed. It can bend, it can curve, it can stretch and warp. And what makes it bend? Mass, energy, stuff. When you put something massive in spacetime, like a star or a planet, the fabric curves around it. It bends, it warps. There's a common way to picture this. Imagine a stretched rubber sheet held tight at the edges like a trampoline. Now imagine placing a heavy bowling ball in the center. The sheet curves, it dips down around the ball. There's a kind of valley, a depression, with the ball at the bottom. Now imagine rolling a marble across the sheet. If you roll it far from the bowling ball, it goes mostly straight. But if it passes near the bowling ball, near that dip in the sheet, its path curves. It bends toward the ball. If you roll it just right, it might even circle around the ball for a while, going around and around the depression. This is kind of like what's happening with gravity. The bowling ball is like a massive object, like the sun. The marble is like a smaller object, like the Earth. And the curved sheet is like curved spacetime. The marble isn't being pulled by the bowling ball. There's no invisible rope between them. The marble is simply following the curves in the sheet. It's going straight as it can, but the sheet itself is bent. Now this analogy isn't perfect. The rubber sheet is two-dimensional and spacetime is four-dimensional. Also, the analogy kind of cheats because the bowling ball sinks into the sheet because of Earth's gravity, which is the very thing we're trying to explain. But it gives you a feel for the idea. Massive objects curve the fabric of reality around them, and other objects move through that curved fabric, following the curves. Let me say that again, because it's the most important part. Objects don't move because gravity pulls them. Objects move because spacetime is curved, and they're following the shape of that curve. When you throw a ball into the air, it doesn't fly in a straight line and then get pulled down by some invisible force. Instead, it's moving through curved spacetime. And in curved spacetime, the straightest possible path, the most natural path, curves back toward the Earth. When the Moon orbits the Earth, it's not being pulled by some force reaching across empty space. It's following a path through the curved spacetime around the Earth, and that path happens to loop back on itself. It looks like a circle, but from the Moon's point of view, it's going straight as possible through bent space. When you stand on the ground and feel your weight, you're not feeling gravity pulling you down. You're feeling the ground pushing you up. Wait, what? Yes, this is one of the most surprising parts of Einstein's theory. Think about it this way. Your natural state, your default state, is to fall freely, to follow the curves of spacetime. If there were no ground, you would fall. You would float in free fall, feeling weightless, just like Einstein's man falling off the roof. But there is a ground, and the ground is made of solid matter held together by the forces between atoms, and that ground refuses to let you pass through it, so it pushes against you. It stops your natural motion. It accelerates you away from the path you would naturally follow. That acceleration is what you feel as weight. Let me say that again, because it's so different from how we usually think about it. Gravity isn't pulling you down. The ground is pushing you up, and that push, that acceleration, is what you feel pressing you into your bed right now. Take a moment, feel that pressure, the mattress against your back, your pillow against your head. You've always thought of that as gravity holding you down, but really, it's the bed holding you up, preventing you from falling, accelerating you upward relative to the natural free fall path. In a very real sense, you are being accelerated right now, constantly, just by lying there. This might seem like a trick of words, like we're just redefining things, but it's not. It's a completely different picture of reality. In Newton's view, gravity is a force. Objects want to stay still, and gravity pulls them toward each other. If you're standing on the ground, gravity pulls you down, and the ground pushes back up to balance it out. Two forces canceling each other. In Einstein's view, there is no force. There's just geometry. Spacetime is curved. Objects move through that curve. Free fall is the natural state, the path of least resistance. And when something prevents you from falling freely, like the ground, you feel that prevention as weight. This is why astronauts feel weightless. They're not escaping gravity. Up in the International Space Station, gravity is still about 90% as strong as it is on Earth's surface. The astronauts are absolutely in a gravitational field. But they're falling. They're in orbit, which means they're falling around the Earth, not toward it. They're following the curved spacetime around Earth, and nothing is stopping them. No ground, no floor, nothing pushing against them, so they feel nothing, they float. They're in free fall, and free fall is the natural state, the state where you don't feel gravity at all. Let's rest here for a moment. Take a slow breath, let your shoulders relax, let your jaw unclench. If there's tension anywhere in your body, let it soften. We've covered a lot, and there's more to come, but there's no hurry. The universe has been doing this for billions of years. It can wait a few more minutes while you settle deeper into your pillow. Gravity is not a force, it's the shape of spacetime. Objects follow the curves. Free fall is the natural state. Weight is what we feel when something prevents us from falling. These ideas are strange. They're different from everything we learned as children, but they're true. They describe reality more accurately than Newton's ideas ever could. And there's more, because Einstein didn't just discover that space curves around massive objects. He discovered that time curves too. Time, that endless river that seems to flow the same for everyone. Second after second, minute after minute, carrying us all forward at the same pace. Except it doesn't. Einstein discovered that time is not absolute. Time is not the same everywhere. Time is part of spacetime, and spacetime curves near massive objects, which means time curves too. Near something massive, like a planet or a star, time passes more slowly. This sounds like science fiction, but it's not. It's been measured. It's been confirmed. It's so real that the technology you use every day depends on it. Right now, about 20,000 kilometers above your head, there are satellites orbiting the Earth. GPS satellites. They help your phone figure out where you are. They do this by sending out time signals, incredibly precise signals from atomic clocks, and your phone uses those signals to calculate its position. But those satellites are far from Earth. They're higher up, where gravity is weaker, and because of that, time passes slightly faster for them than it does for you. How much faster? About 45 microseconds per day. That might not sound like much, 45 millionths of a second, but light travels almost 300,000 kilometers in a single second. So in 45 microseconds, light travels about 13 kilometers. If we didn't correct for this time difference, GPS positions would drift by 10 kilometers per day, within a few minutes. Your navigation would be completely useless. But we do correct for it. The engineers who built the GPS system knew about Einstein's theory. They programmed the satellites to adjust their clocks, accounting for the fact that time moves faster up there than it does down here. Every time you use GPS, every time you look at a map on your phone and see that little blue dot showing where you are, you're using Einstein's theory of gravity. You're benefiting from the discovery that gravity is not a force, but the curvature of spacetime. There's another effect too. The satellites are moving fast, about 14,000 kilometers per hour. And according to Einstein's earlier theory, his special theory of relativity, time passes more slowly for moving objects than for stationary ones. So the satellites have two effects working on them. Being higher up makes their clocks run faster. Moving quickly makes their clocks run slower. These effects partly cancel each other out. The net result is that the satellite clocks run about 38 microseconds faster per day than clocks on the ground. And the system accounts for this automatically, constantly, keeping your GPS accurate to within a few meters. It's remarkable. Two of Einstein's most abstract, most mind-bending ideas built into a technology that billions of people use every day without ever thinking about it. Take another breath. Feel how your body has settled deeper into the bed. Feel how your mind has quieted just a little as these ideas have washed over you. We're not in a hurry. The night is long and these thoughts are gentle. They're not demanding anything from you. They're just here like starlight, shining quietly whether you watch them or not. Let's go back to Einstein, sitting in his patent office, dreaming about falling men and accelerating elevators. He had this idea that gravity and acceleration were the same thing, that you couldn't tell the difference between them, and he started thinking about what that meant. If light moves in a straight line through an accelerating elevator, what does that look like to someone inside? If gravity and acceleration are the same, what does that mean for light in a gravitational field? Einstein realized that light must bend in a gravitational field, not because gravity is pulling on the light. Light has no mass, but because light is traveling through curved spacetime. And in curved spacetime, the straightest path is not a straight line in the usual sense. It's a curve. Imagine a beam of light passing near the sun. The sun is massive. It curves spacetime around it, and the light, following the curves, bends slightly as it passes. Einstein calculated how much the light should bend, and then he waited for someone to test it. The test came in 1919. There was a total solar eclipse, when the moon blocks out the sun's light and you can see the stars that are normally hidden by the sun's glare. Scientists traveled to two locations to observe the eclipse, one in Brazil and one on an island off the west coast of Africa. They photographed the stars that appeared near the edge of the darkened sun. Then, they compared those photographs to photographs of the same stars taken months earlier, when the sun was in a different part of the sky. The stars near the sun appeared to have shifted position, just a tiny bit, about 1.75 arcseconds, which is less than 1,000th of a degree, but it was exactly the amount Einstein had predicted. The light was bending around the sun, not because the sun was pulling on it, but because the sun was curving spacetime and the light was following the curves. The news went around the world. Einstein became famous overnight. Headlines declared that Newton had been overthrown. A new theory of gravity had been confirmed. But Einstein didn't really overthrow Newton. That's not quite right. Newton's equations still work. They're still accurate enough for almost everything we do. When engineers calculate the trajectory of a rocket, they use Newton's math. When astronomers predict where a comet will be next year, they use Newton's math. For ordinary situations, with ordinary masses and ordinary speeds, Newton's gravity is perfectly fine. What Einstein did was show that Newton's theory was incomplete. It was an approximation. It worked beautifully in most cases, but it missed something deeper. It missed the true nature of what gravity actually is. Newton said gravity was a force. Einstein said gravity was geometry. Newton said objects pull on each other across empty space. Einstein said there is no empty space. There's only space-time, curved and warped by mass, and objects follow the curves. Newton's theory couldn't explain why Mercury's orbit wobbled slightly more than expected. There was a tiny discrepancy, just 43 arcseconds per century, that no one could account for. Scientists proposed invisible dust clouds, undiscovered planets, all sorts of explanations. None of them worked. Einstein's theory explained it perfectly. Mercury is the closest planet to the sun. It's deep in the sun's gravitational well, deep in the curve of spacetime around the sun. And because of that curvature, its orbit doesn't quite close. Each time Mercury goes around, its closest point to the Sun shifts slightly. Over a century, those shifts add up to 43 arcseconds. Einstein did the calculation. He got exactly the right number. Without any fudging, without any assumptions, his theory of curved spacetime predicted the exact amount of wobble that had puzzled astronomers for decades. He later said that when he got that result, he felt something physical happen in his chest. His heart pounded. He knew his theory was right. Let your breath slow, let your thoughts drift. We've traveled a long way tonight, from Newton's apple to Einstein's elevator, from invisible forces to curved spacetime, from GPS satellites to the orbit of Mercury. And there's still more, because Einstein's theory made another prediction, a prediction so strange, so seemingly impossible, that Einstein himself thought we might never be able to test it. He predicted that when massive objects accelerate, they create ripples in spacetime, like throwing a stone into a pond, ripples spreading outward, distorting the fabric of reality as they go. He called them gravitational waves. Imagine two black holes, massive beyond imagination, each one the corpse of a giant star that collapsed under its own gravity, each one so dense that nothing can escape it, not even light. Now imagine those two black holes spiraling toward each other, getting closer and closer, moving faster and faster, each one caught in the curved spacetime of the other. As they spiral, they accelerate, and as they accelerate, they send out ripples, gravitational waves spreading outward through the universe at the speed of light. Finally, they collide. They merge into a single, larger black hole, and in that final moment, they release an enormous amount of energy. Energy so immense that, for a fraction of a second, they release more power than all the stars in the visible universe combined. All that energy goes into gravitational waves, ripples in spacetime, spreading outward from the collision, traveling across the cosmos. Over 1 billion years, those ripples travel through space. They pass through galaxies and across the voids between them. They barely interact with anything, passing through matter like a whisper through fog. And on September 14, 2015, those ripples reached Earth. We had been waiting for them. Scientists had built detectors, incredibly sensitive instruments designed to catch these faint ripples as they passed by. The detectors are called LIGO. There are 2 of them, one in Louisiana and one in Washington state. Each one is shaped like a giant L, with arms 4 kilometers long. Laser beams travel back and forth along those arms, measuring the distance between mirrors with incredible precision. When a gravitational wave passes through, it stretches space in one direction and squeezes it in another. The mirrors move just slightly, and the laser beams detect that motion. How slight, the motion detected in September 2015 was about 1/10,000th the width of a proton. A proton is already unimaginably small, the nucleus at the heart of a hydrogen atom, and the motion was a 10,000th of that. But they detected it. The 2 detectors, separated by 3,000 kilometers, both registered the same signal 7 milliseconds apart. The time delay was exactly what you'd expect for something traveling at the speed of light across that distance. Scientists analyzed the signal, they decoded it, and they figured out what had caused it. 2 black holes, about 36 and 29 times the mass of our Sun, had spiraled together and collided. The collision happened about 1.3 billion years ago, 1.3 billion light-years away from us. The gravitational waves had been traveling ever since. In that collision, about 3 times the mass of the Sun was converted directly into energy and radiated away as gravitational waves. 3 suns worth of matter transformed into ripples in the fabric of spacetime. And those ripples reached us as a barely perceptible shiver, a stretch and squeeze of space smaller than the smallest thing we can imagine. But we caught it, we heard it, we detected the actual vibration of spacetime itself. That detection confirmed Einstein's last great prediction. Gravitational waves are real. Spacetime is real. It curves, it ripples, it carries the energy of distant cosmic events across billions of years. Since that first detection, we've heard many more, hundreds of black hole collisions, neutron stars spiraling together, cosmic events that we could never have witnessed with telescopes because they don't produce light. They produce gravitational waves, ripples in the geometry of the universe. We've opened a new window on the cosmos, a new way of seeing, not with light, but with the vibration of spacetime itself. Let's pause here, let's rest. You've been lying there, breathing slowly, listening to these ideas drift past. Maybe some of them settled into your mind. Maybe some of them floated by without leaving a trace. Either way is fine. The universe is curved. Space and time are woven together into a fabric that bends around massive objects. We move through this curved fabric, following the natural paths, the geodesics, the straightest possible lines through bent space. Gravity is not a force pulling you down. Gravity is the shape of reality itself, and you are part of that reality. Your body, lying there in your bed, is resting in curved spacetime. The earth beneath you is warping the fabric of space and time, and you are held in that warp, following its contours. The bed pushes against you, preventing you from falling freely, and that push is what you feel as weight. But if the bed disappeared, if everything solid disappeared, you would fall freely, and you would feel nothing, no weight, no pull, just the silent, effortless motion through curved spacetime. Free fall is the natural state, the default, the path of least resistance. And in a sense, we're all falling. Right now, the Earth is falling around the Sun. The Sun is falling around the center of the galaxy. The galaxy is falling through the cosmic web of gravitational attraction that shapes the large-scale structure of the universe. Everything is falling, gently, silently, following the curves. Now let's slow down even more. Let the words come more softly. Let the spaces between thoughts grow longer. You don't need to remember any of this. You don't need to understand every detail. The universe doesn't ask anything of you. It just is, and you are part of it. A small part, resting on a small planet, orbiting a modest star, in one arm of one galaxy among billions. But even a small part can feel wonder. Even a small part can sense the strangeness and beauty of it all. Gravity is not a force. That's one of those ideas that, once you really grasp it, changes how you see everything. The ground isn't pulling you, the ground is pushing you, keeping you from falling, holding you up. And when you relax, when you sink into your bed, you're surrendering to that push, letting the mattress do its work, letting your body rest in the curve of spacetime around the Earth. Think about what it means for time to be part of spacetime, for time to curve along with space. Near the Earth's surface, time passes at a certain rate. Up on a mountain, time passes slightly faster. The difference is tiny, but it's real. Clocks at the top of Mount Everest tick a few nanoseconds faster each day than clocks at sea level. Scientists have measured this. They've taken atomic clocks, the most precise timekeepers ever made, and moved them to different heights. Even raising a clock by just 1 meter, just 3 feet, produces a measurable difference. Time runs faster at the higher location. It's not a trick, it's not an error, it's the actual slowing down of time in stronger gravity. Near a black hole, where gravity is extreme, time slows dramatically. An astronaut falling toward a black hole would experience time normally for themselves, but to an observer far away, the astronaut would appear to slow down. As the astronaut approached the event horizon, the point of no return, they would seem to freeze in place, stretched and reddened by the extreme curvature. From the outside, it would take forever for the astronaut to cross the event horizon. But from the astronaut's perspective, they would fall right through in just a few moments. Time is different for different observers. There's no universal clock ticking away the same seconds for everyone. Time is woven into spacetime and spacetime curves. Let these ideas float through you like clouds drifting across a night sky. You don't need to grasp them firmly, just let them pass. Einstein gave us a new picture of reality, a picture in which space and time are united, in which mass curves the fabric of existence, in which gravity is geometry. It's a picture that has been tested and confirmed countless times: the bending of light around the sun, the precession of Mercury's orbit, the gravitational time dilation measured by atomic clocks, the gravitational waves rippling across the cosmos from colliding black holes. All of it fits together. All of it confirms that Einstein was right. Gravity is not a force, it's the curvature of spacetime. Now let's go even slower. Let the pace become like the pace of falling leaves, like the pace of clouds moving across a moonlit sky. You're lying there, held gently by the fabric of spacetime. The Earth curves that fabric around itself, and you rest in that curve. The bed resists the curvature, pushes against you, keeps you from following the natural path of free fall. And this is what you feel as weight. This is gravity in Einstein's view, not a force, but a geometry, not a pull, but a curve. Close your eyes if they're not closed already. Feel your breath moving in and out. Feel the softness beneath you. Feel the quiet. The universe is vast beyond imagining. Billions of galaxies, each with billions of stars, scattered across the curved spacetime of the cosmos. And here you are, one tiny point of awareness, resting on one small planet, thinking about the nature of reality. You don't have to solve any mysteries tonight. You don't have to understand everything. The universe has been here for almost 14 billion years. It will be here tomorrow and the day after, and for billions of years to come. Tonight, you can just rest. Let me tell you one more thing, and then we'll let the words fade into silence. There's a phrase that physicists use to summarize Einstein's theory. It was coined by a scientist named John Wheeler, and it goes like this: matter tells spacetime how to curve. Curved spacetime tells matter how to move. That's it. That's the whole theory in one sentence. The sun tells the spacetime around it how to curve. That curved spacetime tells the Earth how to move. The Earth follows the curves, traces out an orbit, circling year after year. The Earth tells the spacetime around it how to curve. That curved spacetime tells you how to move. You would fall following the curve, but the ground stops you, pushes you up, and you feel that push as weight. It's all geometry, all curvature, all the shape of reality itself. And here's something beautiful to carry with you into sleep. You right now are curving spacetime, just a little. Your body has mass, and mass curves the fabric of existence. The effect is incredibly small, too tiny to measure, but it's there. You are shaping reality just by being. Everything with mass curves spacetime. The bed you're lying on, the walls around you, the trees outside if there are trees, the air you're breathing. It's all curving spacetime, all interacting with the fabric of the universe. We are all woven into it, all part of the same continuous fabric, curving and bending and flowing. The words can fade now, the thoughts can quiet. You've traveled far tonight, through ideas that once seemed impossible. Gravity is not a force. Spacetime curves around mass. Time itself bends in a gravitational field. Free fall is the natural state, the path of least resistance, the motion you would follow if nothing stopped you. And right now something is stopping you, your bed, your pillow, the solid matter beneath you holding you up, preventing your natural fall. Rest in that, surrender to it, let the bed do its work, let the universe hold you in its curved embrace. There's nothing you need to do, nowhere you need to go, no problems you need to solve, just this, just breath, just rest. The night is deep and quiet. The earth spins slowly, carrying you through the darkness toward morning, but morning is far away. There's plenty of time. Spacetime curves around you. Time passes slightly faster for the stars above and slightly slower for the depths beneath. The whole universe is in motion, following curves, tracing geodesics, falling freely through the geometry of existence. And you are part of it, one small aware being, resting on a small planet, held gently by the curvature of space and time. Let your thoughts drift, let them scatter like dust in a beam of moonlight, let them fade. Sleep is its own kind of free fall, a letting go, a surrender to the natural state. Just as an astronaut floats weightless when nothing pushes against them, you can float now in the darkness behind your eyes. Nothing pulling, nothing pushing, just drifting. The ideas we've talked about tonight are old now, over a century old, but they still feel new, still feel strange, because they go against our everyday experience. We feel like gravity pulls us down. We feel like we're stationary when we stand on the ground. But we're not. We're being accelerated, held up, pushed away from the natural geodesic path. And time is passing for us at a specific rate, different from the rate it passes for someone higher up or lower down. The universe is stranger than it seems, more beautiful, more interconnected. And you are part of it, always have been, always will be. Let the breath carry you now, in and out, slow and steady. There's a rhythm to it, like the rhythm of waves on a shore, like the rhythm of the moon orbiting the Earth, falling forever, never landing, like the rhythm of the Earth orbiting the Sun, year after year, following the curves of spacetime. Everything is moving, everything is falling, and in that falling there is peace, in that falling there is rest. You can let go now, let the words dissolve, let the thoughts fade, let the night wrap around you like a soft blanket. The universe will keep doing what it does. Stars will curve spacetime around themselves. Planets will follow their orbits. Gravitational waves will ripple outward from distant collisions, passing through galaxies and through you without you ever knowing. And time will keep passing at slightly different rates depending on where you are in the gravitational field. But you don't need to worry about that. You can just rest. Tomorrow or someday, maybe you'll think about these ideas again. Maybe you'll look up at the sky and remember that the sun is curving spacetime and the earth is following the curve. Maybe you'll feel your own weight and remember that it's the ground pushing up, not gravity pulling down. But for now, forget it all, let it go, let your mind empty. Sleep is waiting, it's been waiting all along, and there's nothing more natural than to fall into it. Fall gently, fall freely, there's nothing to resist, nothing to hold on to, just the soft, quiet descent into rest. Gravity is not a force, and sleep is not a struggle, both are just the natural way of things, the path of least resistance, the curve you were always going to follow. So follow it now, let it take you, let the night hold you. And rest. The universe is vast, the night is deep, and you are here safe, held at peace. Breathe. Rest. Sleep. Continued presence without new information. The narration becomes ambient, repetitive, dissolving into pure restfulness. The curve of spacetime holds you, the bed beneath you holds you, the quiet darkness holds you. There is nothing to do, nothing to solve, nothing to understand. Just breathing, just resting, just falling gently into sleep. Spacetime curves. Objects follow the curves. You follow the curves now into rest. The universe is geometry, and you are part of the geometry, resting in it, held by it. Safe, quiet, at peace. Let the words fade. Let the thoughts dissolve. Let the night carry you. Sleep. The narration continues with increasingly sparse packing, allowing long silences to settle in. Gravity is not pulling you down. The bed is holding you up. And you can rest in that holding. The Earth curves spacetime around itself. You rest in that curve. Safe, still, breathing slowly. Time passes. Stars shine. The universe unfolds. And you are here, resting. The moon orbits the Earth, falling forever. The Earth orbits the sun, following the curves. And you orbit nothing but sleep now, falling gently into dreams. No force is pulling you, just the natural path, the geodesic of rest, the straightest line through the night. Breathe, rest, sleep. The fabric of spacetime holds everything. The stars, the galaxies, you, held, Savor. Quiet. The words can stop now. The ideas can settle like dust after a long journey. And you can rest. Sleep. Extended silence. The narration presence remains, but no new content, simply a quiet companionship in the darkness. Still here. Still quiet. Still resting. The universe goes on. The curves continue. And you sleep within them. Safe. Held. At peace. The narration dissolves into silence, leaving only the quiet presence of rest. End of Part 1. Part 2 continues seamlessly from this point, maintaining the ambient, restful quality while allowing the listener to drift deeper into sleep. The transition is imperceptible. Part 2 begins. The night continues. If you're still awake, that's fine. There's no hurry, no expectation. Some people take longer to drift off, and that's just how it is. The words are here if you want them, or they're here even if you don't. Either way. Let's talk a little more. Softly, gently, like friends sitting together in the dark, speaking quietly so as not to disturb the stillness. We've covered the big ideas. Gravity is not a force. Spacetime curves around mass. Objects follow the curves. Free fall is the natural state. Weight is what you feel when something prevents you from falling freely. But there's more to say, not because you need to know it, not because it's important, just because the night is long and the ideas are gentle, and sometimes it's nice to have a voice in the darkness. Think about what it means for the universe to be made of curved spacetime. It means that empty space isn't really empty. It means that even the vacuum between the stars has a shape, a geometry, a way of being. It bends and curves in response to the matter and energy within it. Before Einstein, people thought of space as a stage, a fixed, unchanging background against which things happened. Objects moved through space, but space itself did nothing. It was just there, like an empty room waiting to be filled. Einstein showed us that space is not a stage. Space is an actor. It responds to what's in it. It curves around stars. It warps near black holes. It ripples when massive objects collide. Space is dynamic, alive in a sense, always changing, always responding, always interacting with the matter and energy that fills it. And time is part of it. Time is not separate. Time is woven into the fabric, and when the fabric curves, time curves along with it. This is why clocks run slower in stronger gravity. This is why time passes differently at different heights. The fabric is stretched and compressed in different ways at different places, and time is part of that fabric. If you could hover near a black hole just outside the event horizon, time would pass incredibly slowly for you compared to someone far away. You might spend what feels like a single day, and when you returned, centuries would have passed in the outside universe. Time is relative. It depends on where you are and how you're moving. There is no universal clock. There is no single now that applies to the whole universe. This is strange. It goes against our intuition. We feel like time is absolute, like everyone shares the same present moment. But they don't. The present is different for different observers. What is happening now for you is not the same as what is happening now for someone moving differently or in a different gravitational field. But don't worry about that. Don't try to wrap your head around it completely. These ideas have baffled physicists for over a century. They're not meant to be easily understood. They're meant to be contemplated slowly over time. The universe is stranger than we can fully imagine, but we can catch glimpses. We can sense the shape of it, even if we can't see the whole thing. Let your breath continue its slow rhythm, in and out, in and out. The earth spins beneath you. The stars wheel slowly overhead. The moon, if it's up tonight, follows its curved path through spacetime, falling endlessly around the earth. Everything is in motion, everything is following curves, and yet there is stillness too, the stillness of your body resting, the stillness of your breath moving in and out, the stillness of the night. Here's something else to think about if you're still thinking. If you've drifted off, that's fine. These words will be here whether you hear them or not. The equivalence principle, the idea that gravity and acceleration are indistinguishable, has a beautiful implication. It means that in a small enough region of space, over a short enough time, you can always find a frame of reference where gravity disappears. Think about that. If you're falling freely, gravity is gone. In your immediate vicinity, everything behaves as if there's no gravity at all. Objects float. Light travels in straight lines. The laws of physics are the same as they would be in empty space, far from any planet or star. This is what Einstein meant when he said that free fall is the natural state. In free fall, you're following a geodesic, the straightest possible path through curved spacetime. And in your local neighborhood, along that path, everything is simple. Everything behaves as if gravity isn't there. It's only when you look at larger distances, over longer times, that you see the curvature. That's when you notice that two people falling side by side gradually drift toward each other because they're both falling toward the same center. That's when you notice that the geodesics aren't parallel, that spacetime is curved. Locally, free fall is like floating in empty space. Globally, free fall reveals the curvature of the universe. This is the dance between the local and the global, the small scale and the large scale, the immediate experience and the wider pattern. In your immediate experience, lying in your bed, you feel weight. The mattress pushes against you. You feel solid and grounded. But from a wider perspective, you're resting on the surface of a planet that's falling around a star, which is falling around the center of a galaxy, which is moving through a universe that's expanding in all directions. You're falling right now, have been your whole life, will be for the rest of it. Free fall, held in place by solid matter, that's what standing on a planet is. The night goes on, the words go on, but you don't have to follow them anymore. You can drift. You can float. You can fall gently into sleep. Let me tell you about one more thing, a small thing, a quiet thing. When Einstein first worked out his theory, he was alone, working in his apartment, scribbling equations, crossing things out, starting over. It took him years. The math was incredibly hard. He had to learn new kinds of mathematics just to express his ideas. And when he finally got it, when he finally derived the equations that describe how spacetime curves in response to matter, he was overwhelmed. He later wrote that his heart beat faster when he saw the answer. He knew in that moment that he had found something true, something deep, something about the actual structure of reality. And then he tested it. He used his equations to calculate the precession of Mercury's orbit, that stubborn 43 arcseconds per century that Newton's theory couldn't explain. He got exactly the right answer. In that moment, alone in his room, Einstein knew. He knew that gravity was geometry. He knew that spacetime was curved. He knew that he had uncovered a secret the universe had been keeping for 14 billion years. And he was 36 years old, a patent clerk, a man who had failed to get a university job, a man who was largely unknown outside a small circle of physicists. But he had seen something true, and that truth would change everything. Isn't that remarkable, that a single person, thinking hard enough, imagining freely enough, could discover the shape of reality? The universe is comprehensible. That's one of the strangest things about it. We can understand it. Our minds, evolved on a small planet to find food and avoid predators, are somehow capable of grasping the deepest truths of existence. Einstein thought this was the most incomprehensible thing about the universe, that it is comprehensible. And here you are, lying in the dark, following along with these ideas, understanding at least a little what Einstein understood, seeing at least dimly what he saw. You don't need a degree in physics. You don't need to know the math. The core ideas are simple enough to hold in your mind. Gravity is not a force, it's the curvature of spacetime. Objects follow curves. Free fall is natural. Weight is resistance. That's it. That's the heart of it. And now the heart can rest. The mind can quiet. The body can sink deeper into the soft embrace of the bed. Spacetime curves around you. Time flows at its own pace, slightly different here than somewhere else, but who cares? You're here, you're breathing, you're safe. The universe has been doing this for billions of years, curving, bending, warping, holding everything in its geometric embrace. Stars and planets and galaxies, all following their geodesics, all falling freely through the cosmic fabric. And you're part of it, one small point of awareness, resting for a moment in the endless flow. The words can become sparse now, the thoughts can thin out. You don't need to follow them, you don't need to understand them, just let them be like distant stars, bright points in the darkness. There if you look, but no demand to look. Gravity is geometry. Spacetime curves. Objects follow the curves. Free fall is natural. Weight is resistance to free fall. That's the whole story. And you can rest now. The universe is vast and strange and beautiful. And you are part of it. Resting, breathing, falling gently into sleep. The bed holds you. The night surrounds you. The curved spacetime of Earth cradles you. There is nothing to do, nothing to solve, nothing to worry about. Just rest, just breathe, just sleep. The ideas have settled now. They're part of you in some small way, or they're not. Either way is fine. Tomorrow you might remember that gravity is not a force, or you might not. The universe doesn't care. It just goes on curving, bending, holding everything in its vast geometric web. And you go on too, breathing, resting, living. For now, just rest. The night is deep. The silence is soft. And you are held. Safe, quiet, at peace. Sleep. Let the last traces of thought dissolve. Let the darkness wrap around you. Let the quiet fill you. There is nothing more to say, nothing more to know. Just this, just rest, just sleep. The night continues its slow turning. The earth rotates beneath you, carrying you through the darkness, and somewhere on the other side of the planet, the sun is shining on people who are awake, going about their day. But here, where you are, it is quiet, it is dark, it is time for rest. And if you're still listening, still awake, that's perfectly fine. Some minds take longer to settle, some thoughts take longer to quiet. There's no right way to fall asleep. There's just the way it happens for you tonight, in this particular moment. We've talked about the big ideas. Gravity is not a force. Spacetime curves around massive objects. Objects follow the curves, tracing out paths called geodesics. Free fall is the natural state, and weight is what you feel when something prevents you from falling freely. These ideas changed everything. They changed how we understand the universe. They changed how we build satellites and navigate spacecraft. They even changed how we think about time itself. But there's something else worth mentioning, something quieter, something more personal. Think about what it means to be held. Right now you are being held. The mattress beneath you is holding you up. The floor beneath the mattress is holding the mattress. The building is holding the floor. The earth is holding the building. And spacetime, curved by the earth's mass, is holding everything in place. You are nested in layers of holding, layer after layer of support, going all the way down to the fabric of reality itself. In Newton's view, you're being pulled down by gravity and pushed up by the ground. Two forces fighting each other with you in the middle. In Einstein's view, there's no fight. There's just the shape of things. The Earth curves spacetime. You would naturally follow that curve, falling toward the center. But the ground is there, solid and stable, and it accelerates you gently upward, away from the natural path. That acceleration is what you feel. That's your weight. That's the sensation of being held by the earth. Being held, it's such a fundamental experience. From the moment you were born, you've been held. By arms, by hands, by cribs and beds and chairs. By the ground beneath your feet when you learn to walk. By the whole planet, every moment of your life. We take it for granted, we don't think about it, but it's always there, the Earth holding us, supporting us, keeping us from drifting off into space. And now you know what that holding really is. It's not a force pulling you down, it's the ground pushing you up. It's the geometry of spacetime, curved by mass, and the solid matter of the Earth resisting that curvature. You are being held by the shape of reality itself. Let that settle, let it sink in like water into soft earth. You don't need to do anything with this knowledge. You don't need to remember it or apply it. Just let it be part of your experience tonight, a quiet awareness resting beneath your thoughts. The universe is holding you, has always been holding you, will continue to hold you. Take a slow breath, feel the air fill your lungs, feel it leave again, feel the rhythm of it, steady and patient, like waves on a distant shore. The breath is another kind of holding. The air holds the oxygen your body needs. Your lungs hold the air. Your blood holds the oxygen and carries it to every cell. Each cell holds the oxygen and uses it to burn fuel and keep you alive. Layers of holding, systems within systems, everything supporting everything else. And the same is true the scale of the cosmos. Stars hold planets in their gravitational embrace. Galaxies hold stars. Clusters of galaxies hold galaxies. The whole universe is a web of curved spacetime, everything influencing everything else, everything following the curves. We are part of that web, small threads in an immense tapestry, but threads nonetheless, connected to everything else by the curvature of spacetime. The sun curves the space around it, and we feel that curvature as the warmth on our faces, as the light that lets us see, as the energy that powers all life on Earth. The moon curves space around itself, and we feel it in the tides, in the slow wobble of our planet's axis, in the way the ocean rises and falls twice a day. Everything is connected. Everything influences everything else, not through mysterious forces reaching across empty space, but through the geometry of spacetime itself. This is the universe Einstein revealed to us, a universe of curves and connections, a universe where space and time are woven together, where mass shapes geometry, where motion follows the natural paths through bent reality. It's a beautiful universe, strange, yes, counterintuitive, yes, but beautiful. And you are part of it. You have always been part of it. From the moment the atoms that make up your body were forged in the hearts of ancient stars, to this very moment, lying here in the dark, breathing slowly, resting. You are made of star stuff. You are held by curved spacetime. You are a small eddy in the vast flow of the cosmos. And right now, you can rest. The words keep coming, soft and slow. You don't have to follow them. You can let them wash over you like gentle rain. You can let them fade into the background, becoming just another part of the quiet soundscape of the night. If you're still awake, that's fine. If you've drifted off, that's fine too. The words are here either way, patient and unhurried. Let me tell you about something called the geodesic equation. Don't worry, this isn't a math lesson. You don't need to know the equation. You don't need to understand how it works. I just want you to know that it exists and what it represents. The geodesic equation is the mathematical description of how objects move through curved spacetime. It tells you the path that a freely falling object will follow. It captures, in precise mathematical terms, the idea that objects move along the straightest possible paths through bent space. Einstein derived this equation as part of his theory of general relativity. It's one of the most beautiful equations in all of physics. It describes the motion of planets around stars, the bending of light near massive objects, the spiraling of galaxies, the expansion of the universe itself. All of that captured in a single equation. And the remarkable thing is, the equation doesn't mention forces. There's no force of gravity in the geodesic equation. There's just geometry, just curvature, just the shape of spacetime telling objects how to move. That's what it means to say gravity is not a force. It means that the motion of objects in a gravitational field can be described purely in terms of geometry. No forces needed, just curves. This is the elegance of Einstein's theory. It takes something complicated, something mysterious, something that had puzzled people for centuries, and reduces it to geometry, to shapes, to the fundamental structure of space and time. Newton's theory required a mysterious force that reached across empty space. Einstein's theory requires no such force, just curved spacetime and objects following the curves. It's simpler in a way, more elegant, more unified. And it works. It predicts things that Newton's theory can't predict. It explains things that Newton's theory can't explain. It has been tested and confirmed countless times in countless ways. Gravity is geometry. That's the truth Einstein uncovered. And it's one of the deepest truths we've ever discovered about the nature of reality. But you don't need to think about truth right now. You don't need to think about anything. Just rest, just breathe, just let the night hold you. Here's something gentle to carry with you. When you look up at the night sky, if you ever look up at the night sky, you're seeing light that has traveled vast distances to reach you. Light from stars that might be hundreds or thousands of light years away. Light that left its source before you were born, before your parents were born, before your great-great-grandparents were born. That light has traveled through curved spacetime the whole way. It has followed geodesics, the straightest possible paths through the bent fabric of the universe. It has curved around stars and galaxies, bent by the mass along its path. And finally, after all that time, all that distance, it reaches your eyes. A few photons, ancient travelers from the depths of space, completing their journey by landing on the back of your retina. You are connected to the stars, not in some vague, poetic sense, but physically. Light connects you, gravity connects you, the curvature of spacetime links everything to everything else. You are part of the cosmos, always have been, always will be. Let your eyes rest now, if they're not already resting. Let them close gently, like leaves settling on still water. The darkness behind your eyelids is its own kind of space, a small, private universe, a place where thoughts can drift and dissolve. You don't need to see anything right now. You don't need to look at anything. Just let the darkness be. Breathing in, breathing out. The rhythm continues, steady and patient. We've talked about how gravity works according to Einstein, but we haven't really talked about what spacetime is. Not deeply, not fully. That's because we don't entirely know. We have equations that describe how spacetime behaves. We can calculate its curvature, predict its effects, measure its ripples, but we don't know what it is fundamentally. Is spacetime a thing, like a substance, or is it just a way of describing relationships between events? Is it made of something even more fundamental, something we haven't discovered yet? These are open questions, questions that physicists are still working on, questions that might not be answered for decades or centuries or ever. And that's okay. We don't need to know everything. We can marvel at what we do know and hold the unknown with curiosity rather than frustration. The universe is full of mysteries. That's part of what makes it beautiful. If we knew everything, if there were nothing left to discover, the universe would be a smaller, less wondrous place. So let the mysteries be. Let them float in the darkness, like stars you can't quite see, but you know are there. Spacetime is mysterious. Gravity is mysterious. The whole universe is mysterious in the end. But it's also comprehensible, at least partly, at least enough to see that gravity is not a force, that spacetime curves, that we are all falling freely through the geometry of existence. That's enough, that's plenty, that's more than enough to rest on. The night deepens, the hours pass. Somewhere the moon continues its orbit, falling endlessly around the Earth. Somewhere the Earth continues its orbit, falling endlessly around the sun. Somewhere stars are being born, and somewhere else stars are dying. The universe goes on, indifferent to our small lives, our small thoughts, our small concerns. And that indifference is strangely comforting. It means we don't have to carry the weight of the universe on our shoulders. It means we can rest, and the cosmos will continue without us. You can rest now. You don't have to listen anymore. You don't have to think anymore. You can just be. Be here in your bed. Be here in the quiet. Be here in the curved spacetime of Earth, held gently by the geometry of reality. If thoughts arise, let them. Don't fight them. Don't chase them. Just let them float through like clouds drifting across a night sky. Thoughts about gravity, thoughts about spacetime, thoughts about tomorrow, about yesterday, about nothing in particular. Let them all pass. They don't need your attention right now. They can take care of themselves. The only thing that matters right now is rest. The only thing you need to do is breathe. The only thing you need to be is here. Here in this moment, here in this place, here in the vast, curved, mysterious universe. Safe, held, at peace. Let me tell you one more story, a quiet story, a story about nothing very much. Imagine a leaf falling from a tree in autumn. It detaches from its branch and begins to drift downward. The air catches it, turns it, spins it gently. It falls in a lazy spiral, back and forth, side to side, slowly descending. To the leaf, if a leaf could feel, there would be no sense of falling, no sense of being pulled, just the sensation of floating, of drifting, of moving through air without effort. The leaf is following a path through the curved spacetime around the Earth. It's following a geodesic, modified by the air resistance that makes it spiral and drift. But at its heart, the leaf is in free fall. It's doing the most natural thing in the universe. It's following the shape of reality. Eventually, the leaf reaches the ground. It settles onto the grass or the sidewalk or the surface of a pond. Its fall is over, it rests. And you are like that leaf now, drifting, settling, coming to rest. The day has been long, the thoughts have been many, but now they're quieting, now they're settling, now they're coming to rest like leaves on still water. There's no hurry, the ground is patient, the night is patient, the universe is patient. You can take all the time you need. The breath continues, in and out, in and out. The heart continues, beat after beat, steady and reliable. The body continues, all its systems working, all its processes unfolding without any conscious effort from you. You can trust the body. It knows what to do. It has been doing it your whole life, long before you knew anything about gravity or spacetime or geodesics. The body knows how to rest. The body knows how to sleep. You just have to let it. Let it. Let the muscles relax. Let the jaw soften. Let the shoulders drop. Let the weight of the day fall away. Let the thoughts quiet. Let the sleep come. We started this evening with a question. What is gravity? What is this thing that holds us to the Earth, that keeps the moon in its orbit, that shapes the structure of the entire universe? And we've found an answer. Not the final answer, perhaps, not the complete answer, but an answer that is true as far as we can tell. An answer that has been tested and confirmed in countless ways. Gravity is not a force. Gravity is the curvature of spacetime. Mass tells spacetime how to curve. Curved spacetime tells mass how to move. That's it, that's the secret. That's the truth that Einstein discovered over a century ago, sitting alone in his room, following the threads of his imagination to their logical conclusion. And now you know it too. Or at least you've heard it. You've let it wash over you. Maybe some of it has settled into your mind. Maybe it will surface again tomorrow or next week or next year when you look up at the sky or feel your feet on the ground. Or maybe it will just fade like a dream upon waking. That's okay too. The universe doesn't need you to remember. It just goes on curving regardless. What matters now is rest. What matters now is sleep. What matters now is letting go of everything, including these ideas, and sinking into the quiet darkness. The words are becoming sparse now, thin, like stars at the edge of a galaxy. You don't need many words. You don't need any words, really, just the silence, just the dark, just the breath rising and falling. Spacetime curves. You rest in the curve. Safe, held, at peace. The universe is vast. You are small. And that is perfectly fine. Small things need rest too. Small things need sleep. Small things need the quiet embrace of the night. There's nothing more to say, nothing more to know, nothing more to do. Just this, just rest, just sleep. The night holds you. The earth holds you. The curved spacetime of the cosmos holds you. And you can let go. Completely. Finally. Now. Sleep. The narration presence remains, wordless now, a silent companionship in the darkness. The listener drifts, settles, falls gently into the deep rest they need. The night continues. The universe continues. And somewhere, a small point of awareness finds its way into dreams. Ambient presence continues. No words, just the gentle, patient waiting of the night. If the listener stirs, the voice returns, soft and unhurried. Still here, still quiet, still resting. The night goes on. The universe curves. And you are held. Safe. At peace. Sleep.